The squares of two numbers is 3. Say
Okay, so x plus 4 is...
the difference.
Oh, so x minus y2.
Good. That's it. That's the first equation. The difference of the squares of two numbers is 3. Twice the square of the first.
So 2 times x minus...
Very good. Awesome. Increased by the square of the second number is 9. Find the numbers. It's already set up for us. What? That's it. So then 3x squared equals 12. Very good. Awesome. X squared equals 4. Now? Very good. X equals plus or minus 2. This is good, but not good enough. I go back and replace x squared by 4. 4 minus y squared equals 3. Very good. Awesome. Negative y squared equals negative 1. Very good. Y squared equals 1. Y equals plus or minus 1. The options, please. Say it again. Yes, please.
So when we did the last problem, we did like a 1 and 2, a 1 and negative 2.
Correct.
Why are there two numbers?
Very good. On the previous one.
Mm-hmm.
Okay, let's go back. So it's clear that we get x to be plus or minus 1. Okay, now I have to go back and determine y. And I get y equals plus or minus 2. Is that clear?
Yeah.
Okay, so now when x is 1, which one do I pick?
Oh, so it's y, x, and y.
Exactly.
Okay.
So if I pick 1, then there is no difference. So in other words, when x is 1, I could have two different options.
Okay.
So these, we don't graph them in this class, but these equations are graphs that will cross in 4 different points.
Okay.
Yeah, we do not graph them. They're hyperbolas. We don't graph them in this class. So when x is 1, which one do I pick? Well, it could be either. And then when x is negative 1, it could be either.
Okay.
So the same thing in this problem, right? So when x is 2, which y do I pick? It can be either one. So this is 2, 1, 2, negative 1, negative 2, 1, negative 2, negative 2. We can go back now, since we did not check. Say it again.
What if it's negative 2, negative 1?
So negative
For the
2
last one.
for this one?
Yeah. Yes.
Oh, yes, of course. I'm sorry. So, thank you, of course. Okay, let's go back and check. Let's say I want to check 2, 1. And then you choose another, or we can check all of them. So 2, 1, 2, 1. Let's check. 4 minus 1 is 3. Check. 4 times 2 is 8. 8 plus 1 is 9. Check. Which other, so the first one we check, which other you would like to check? It will not be any problem because once you square them, you will always get the same thing. Because if you square these two, you still get 4 and 1. Like we did here, 4 and 1. 4 and 1. When you square this, you still get 4 and 1. Is that clear? Okay. Any questions? Would you like to see other problems with systems of nonlinear equations? Substitution or elimination? Is that a yes? Okay. Again, the next section is a review, partial review. 5.5. Systems of inequalities, linear and nonlinear. Linear, nonlinear inequalities. Most of it, review. Let's start with a very simple one with linear inequalities. Let's say 30. This part is a complete review, this type of problem from previous classes. Okay, so what is this? Well, obviously, it's a system, two conditions put together, but they are not equations. But they are what? They are inequalities, correct. Very good. Okay, so how do I solve such a system of inequalities with two variables, two inequalities and two variables? Here's the first step. I write the equation corresponding to the first inequality, and you could say, are you changing the problem? And the answer is no. But I need to see the equation and write the equation because I'm going to graph it first. I cannot determine the solutions of this without graphing the equation. I'm not changing anything, but I'm just writing the equation in order to enable us to find two ordered pairs. Okay, so when x is 0, I covered it. How much is y? What is the ordered pair? Very good. Now when y is 0, I covered it. How much is x? So what is the ordered pair? Good. Let's graph. So I'm going to plot 2, 0 and -4, 0. I meant 0, -4, of course. At this point, I'm going to stop. Do not graph. The next thing I have to do is look at this inequality symbol. If it has the equal symbol, then the line will be a solid line. If it does not have the equal symbol, then I have to graph it as a dashed line. But there is an equal symbol there. So it is a solid line. I write on the line 2x minus y equals 4 because that's what I graphed. I graphed 2x minus y equals 4. Now, I hope you agree with the following statement. This line divides the plane into two regions, the region below and the region above. I'm going to use the easiest point to work with. If the line passes through it, I cannot use it. But it doesn't. I'm going to use the point that is the easiest to work with, 0, 0. I'll plug it in. 0, 0. 0 less than or equal to 4. If you say true, I will shade in the area that has 0, 0. If you say no, with 0, 0 you get a false statement, then I'm going to shade in the opposite. So is it a yes? Is this a true statement? It is. So I will have to shade in that area. This represents solutions to 2x minus y less than or equal to 4, including points on the line. I will repeat the same steps for 3x plus 2y equals -6. I need to find two ordered pairs. When x is 0, how much is y? Very good. So 0, comma, -3. And now when y is 0, x equals -2. So -2, 0. I'm going to plot these 0, -3, and -2, 0. I will stop. I will not connect before I look at the inequality symbol. Does it have the equal symbol? No, so I cannot graph it as a solid line. I write on the line 3x plus 2y equals negative 6. I did not graph the inequality yet. I only graphed the equation. I hope you agree with the following statement. This line divides the plane into two regions, the one above and the one below. I'm checking the one above using 0, 0. 0, 0. Is 0 greater than negative 6? If you say yes, then I will shade in this area. If you say no, I will shade in the opposite. 0 is greater than negative 6, so I will shade in 3x plus 2y greater than negative 6. All the red region consists of ordered pairs that satisfy the second inequality. But what I want is the common territory. I want blue and red at the same time, because when I pick a point, I want both inequalities to exist and be correct and be fulfilled, both conditions, right? I don't want here where only one of them works. I don't want to choose points from here when the other one, where the other one works. I don't want to choose points here where none works. I want to choose the common territory. If you want common domain, common area. So points on this line, points very close to this line, but not points on that line at all. Those points on the line will not work, and everything else in between. This is the only way we can present ordered pairs that verify both inequalities at the same time. This is the only way. We cannot present the solution in any other way but by graphing it. Any questions? Any questions? This was a simple situation because we were given two linear inequalities. Now let's look at nonlinear inequalities. Would you like to choose or I will choose? Okay, let me choose 48. Page 600. X squared plus y squared less than or equal to 4 and x plus y greater than 1. These are two inequalities. One is linear, but obviously the other one is not. So I have to be careful. I'll write the equation. I have to, because I have to graph the equation. I'm not changing anything here, but I need to graph the equation. And now we should remember what this is. What is it? Say it again. Awesome. With a center where? At the origin and the radius? Very good, thank you. Awesome. So let's graph it. Very good.
So you'll know that it's a circle if it's the x squared plus y squared?
Yes, because the equation is x minus h everything squared plus y minus k everything squared equals r squared. It happened that I don't have anything to subtract. If it's 0, then I have x squared. If it's 0, then I have y squared, and this is a positive number, and I take the square root from it. So you told me the radius is 2. Stop. What do I do next? Look at the inequality symbol to know, or I make sure that it's a solid curve or a dashed curve. What is it? Solid. This, just the equation of this, is x squared plus y squared equals 4. I did not graph the inequality yet. Now, in this case, I hope you agree with the following statement. The circle divides the entire plane into two regions, the inside and the outside. I'm going to check the inside because I'm going to use the origin. You can say I don't want to choose the origin. Fine. Then you're going to use this point, let's say. -10, +10. And you plug it in and see what happens. I'm going to use the origin because it's the easiest. So 0, is that less than or equal to 4? Yes, it's true. Therefore, the inside, including points on the circumference of the circle, consists of all possible solutions of this inequality. If I pick here -10, 10, look what happens. -10 squared is 100. 10 squared is 100. 100 plus 100 is not less than or equal to 4. So only points inside the circle will make this inequality true. Now I will repeat for x plus y equals 1. Now this is a line. When x is 0, how much is y? So it's 0, 1. When y is 0, how much is x? 1. So 1, 0. Good, so let's graph. So 0, 1 and 1, 0. Now I stop. Why? Where am I looking? The inequality symbol. There is no equal symbol in it. So, yes. On the line I write x plus y equals 1. I did not graph the inequality yet. Like before with the linear inequality, I see that it divides the entire plane into two regions, one above, one below. Of course, I'm happy that it doesn't pass through the origin. I can use my special point 0, 0. So I plug it in. 0 greater than 1. If you say yes, I will shade in this. If you say no, I have to shade in the opposite. I have to shade in the opposite. So it's false. This is x plus y greater than 1. The blue region consists of all ordered pairs that make the inequality, the second inequality, true. But I'm not interested in the second one, and I'm not interested in the first one. I'm interested in the system. Do the red and the blue regions intersect? If they do, then the system has solutions. If they don't, the system has no solutions. They do. Right here. All points on this curve, all points extremely close to the line, but not points on the line, and everything in between. What does this represent? Both. Solutions of the system. Any questions? Any questions? Ready for another? No more new material. I'm just practicing now. So what is left for next Tuesday is basically two sections, 6.1 and 8.1. And then we can review for the test. And we'll have hopefully an extra session to review as well. Say it again. I'm sorry? Yes, but the following Tuesday we'll review. Yes. Okay, so let's take a look at another. Any preference? Any type of function? Any preference? Yes, let's take a look at this one, 46. On page 600. Y greater than or equal to x squared minus 4. X minus y greater than or equal to 2. Is this a linear system of inequalities or nonlinear? Nonlinear, because this is linear, but this is not linear. Okay, I will start with the first equation. Y equals x squared minus 4. I know from transformations how to graph x squared minus 4. X squared, careful, down 4. Good, so I know that immediately. We didn't even calculate anything. Of course, it will cross at negative 2 and 2, and it will go to negative 4. Well, we didn't really have put in any effort at all. We just remembered x squared and down 4. Okay, solid curve or not?
Solid.
Solid indeed. So this is y equals x squared minus 4. I hope you agree that this curve divides the entire plane into two regions, the inside and the outside. I will choose 0, 0 again. 0, 0. 0 greater than or equal to negative 4. If you say yes, we'll shade in the inside. If you say no, we will shade in the outside. Do we shade in the inside?
Yeah.
So now this, everything inside is y greater than or equal to x squared minus 4. The curve itself is just this equation. All the area inside, including points on the graph, represent solutions to the inequality. So we are done with the first one. Oh, the second one is linear. X minus y equals 2. When x is 0, cover it and determine y. Y equals negative 2. 0, negative 2. When y is 0, x is, yes. When y is 0, x is 2, so we have 2, 0. Two ordered pairs. 0, negative 2, and 2, 0. Stop and look. Solid line or not?
Yeah.
Solid indeed. On the line, I write the equation x minus y equals 2. The line divides everything in two regions. The one to the left, if you want, and the one to the right. I will check the one to the left using the origin again. 0 greater than or equal to 2. If you say yes, I will shade in the area that has the origin. If you say no, I will shade in the opposite. No. So 0 is not. So this is false. This is 0 is not greater than or equal to 2. So then I have this. And this represents x minus y greater than or equal to 2. Okay, I'm not interested in the green. I'm not interested in the black. I'm interested in both. If they don't overlap, if the regions don't overlap, there is no solution. Do they?
Yeah.
Yes, they do overlap. Right here, this line, this curve, and everything in between. Just this little piece. If you pick ordered pairs here, those ordered pairs will verify both inequalities. And now I'm sure it's probably on your mind. Why do I need to study this? We in the past, I don't know why we changed this. I don't remember. I'm not on this committee. In the past, we would determine the feasible region. We will have a function to deal with, and we will determine the maximum, the min, which is called optimization and finding a max or a min of a function, right? We don't do that anymore. So I can't really show you a lot of applications of what we're doing now. I don't know why we removed that. Can't remember why we decided, or it came from the Maryland Department of Education. I don't remember why we took linear programming out. It's called linear programming. It's section 5.6, but it's not in the curriculum anymore. Okay, so We do have 6 more minutes, so let's choose what you would like, nothing new. Let's choose what you would like me to go back to. Maybe substitution, maybe elimination, maybe more of this graphing. What would you like?
Substitution.
Substitution. Systems that are linear or nonlinear? Nonlinear. Awesome. Very good. So on page 587, let's look at 25. So here's a system. X squared plus y squared equals 25. And x minus 8, everything squared, plus y squared equals 41. Let me see if I copied from, sometimes I copy from 2 different problems. X squared plus y squared 25, correct. X minus 8, yes, correct. I did copy from 1. Okay. Yes, linear programming was interesting and it was fun, but okay, I'm looking at these 2 equations and I'm asked to use elimination. Can I eliminate x? No. Can I eliminate y? Yes. The easiest thing would be to multiply the first equation both sides by? Do you agree with -1? Okay, perfect. So please dictate the first equation. When we multiply both sides by -1, negative x squared, very good, equals -25, negative. Good. Now I copy x minus 8 squared and plus y squared equals 41. And yes, for now at least, we accomplished our mission. But now I have to be careful. I will have to copy negative x squared, but when I add, I have to find how many terms. Careful. 3 terms. Very good. First term squared. Minus 2 minus 16x plus 64 equals 41 minus 25 is 16. Very good. Awesome. Luckily, these 2 go away. So it's not even quadratic. It's linear. So I have negative 16x equals, I have to move 64. So 64 minus 16. 48 with minus. Because it should have been 16 minus 48. But I knew it was going to be a negative number, so I calculated for 64 minus 16. Good. So then from here I know that x equals. Very good. It's good, but it's not good enough. I have to go back here. The equation was actually x squared plus y squared equals 25, so I prefer putting it here. 9 plus y squared equals 25. So y squared equals 16. 2 solutions because it's quadratic. Very good. And now, very good. Very good. Very good. Any questions on this? Any questions? I am